Hey, what's up? This is Anupam. Welcome back. This is the third tutorial on the video tutorial series on STM32F4 Discovery Board. You can check out this website www.logicvoltage.com. You'll find all these tutorials there also. You can even check out the video store at the website. You'll find very good video tutorial series there with a very less price. People are buying it, talking about it. You can also buy it and I'm sure you will not be disappointed. You can also get in touch with me in case of any query. Just go to contact us page and fill up the form and I will reply. You can check out the forum also. For any tutorial related queries, you can post comment there and I will reply back there so that other people can also see the comments and what discussion is going on. Please make some donations so that we can continue to create the free tutorials. You are welcome to choose any amount as you like for donation. Will be highly appreciated. You can also support us by giving a thumbs up at this YouTube video and subscribe my YouTube channel. Thanks. Okay, in the previous tutorial we have talked about datasheet. Then we have written a basic program to switch on the LED, green LED on the STM32F4 Discovery board. So now in this tutorial we'll continue further. We'll understand the libraries that were used in the program and then we will change the LED program to make the green LED blink in every 1 second. Okay, so now let's get back to our LED program that we have already written. If you have gone through with the previous tutorial, one question might have came on your mind that do I have to remember all these function names, these structure definitions? Well, you do not need to worry about this as you do not need to remember. Now let's take example of this declaration GPIO init type def. This is defined in STM library. If you go to STM32F4XX GPIO.h, you will find that. Now go down, see here you will get this. Here you can see that we have these properties in the structure: GPIO pin, GPIO mode, GPIO speed, GPIO O type, then GPIO POPD. The first one, GPIO pin. In this we need to mention the pin number. If you go little down in this header file, you can see the list of all the pins you can mention. Like you can see that in our program we mentioned pin number 12. Same with GPIO mode. Here you need to mention the mode of the pin. If you go a little upwards in the header file, then we can see a list of all the modes it can have. As you can see, we have GPIO mode in, GPIO mode out, GPIO mode AF, GPIO mode AN. Now GPIO mode IN means pin will work in input mode. GPIO mode out means the pin will work in output mode. GPIO mode AF means the alternate function mode, and the GPIO mode AN means analog mode. Now if you go back to our LED program, then you can see that we have declared GPIO mode out. That means our pin 12 is in output mode. Now we have the input analog alternate function mode. These are also used in many other situations. Like if we connect a switch on a pin and we want the pin to detect when a switch is pressed, then in this case we will make the pin in input mode. We will discuss them in future tutorial where we'll use a switch and work on it. Alternate function and analog mode, I will explain what are these modes and when to use them in later tutorials. But for now, just keep in mind that we have 4 options to choose. Then we have GPIO speed. If you go a little up in the header file, then we can see that we have 4 options to choose: 2 MHz, 25 MHz, 50 MHz and 100 MHz. Well, here speed actually means the refresh rate at which the pin should work. Well, here in this LED program it doesn't make any difference if we choose 2 MHz or 50 MHz. Only difference will be in the power consumption. 50 MHz will take a slightly more power than 2 MHz. The situations where choosing speed makes a difference that we will look in later tutorials. For now, just keep this in this way. Next we have GPIO O type. If we go up slightly, then we have two options here. One is push pull and the other is open drain. As you can see that in our program we have used the push pull. That's because we want the pin connected to LED to give logic voltage 3 or 0. But in open drain it could be anything between that. I will show you in later tutorials when we needed this open drain output type. But in most of the situations you will use the push pull configuration. Then we have GPIO PU PD. If we go up, then we have three options to choose, either no pull or pull up or pull down. Here pull up means pin will be in high state or high voltage, and pull down means pin will be in low stage or zero voltage. While here in this LED program we didn't set any value on this property as it doesn't need it here. But I will show you in later tutorials where it is needed. For now, just keep it this way. Now after setting all these values in our main LED program, we have next line GPIO init, then pass to power argument GPIO D and then GPIO LED. This line is actually calling a function and passing two arguments. Now if you press Ctrl key on keyboard and then click on that function, then you will be directly go to that function definition or body, function body. So now we STM32F4XX GPIO.c file opened here. Now here the actual process is done. Whatever the values that we have set earlier are passed into this function, as well as we passes the GPIO port, which is port D. We have passed. So this function is actually setting values in registers of the microcontroller in this discovery board. Hence, as I said earlier, that library are useful in many ways, as you don't have to remember each register names. You just call these functions and pass few arguments and they will automatically initialize the registers on the chip. Although you can go yourself with this function body and understand all the things here, like how it is actually setting register values and all that. It will help you to understand the things in detail. But in reality you will always find a situation that you will be using just the libraries and it will automatically take care of all the background things for you. Okay, hence in our LED program after this line all registers are properly initialized. Now next line is GPIO write bit, then GPIO D, GPIO pin 12 and then bit set. In this line we are calling a function that actually makes the PD12 pin to give output 3 volt. If you go to its function definition by again that holding the control key on keyboard and clicking on it, then you will be direct to its function body like this. And you can see we have redirected to its function body on STM32F4XX GPIO.c file, and it is also from the library. Now this function is actually setting the bit in a register that is pointing to 12th pin on port D, because we are passing here pin 12 and port D, and setting the bit means give logic 1 on pin 12 and that means 3 volt. Hence our LED is light up. Okay, before we go further, let me delete these lines. Actually, we do not need these lines. They are not in use in any way in our program. It's just an integer declaration and nothing else. It came by default here when we created the project. We do not need it. And also in this while loop also we do not need these lines. Let me delete those. It will not change anything on our program. Now next thing is while loop. Now while loop is blank and there is no condition in the loop. Although previously the I++ was written in the loop, but there is no condition which can tell like when this loop will stop. That's because the loop should be an infinite loop. Our program should never come out of that loop. If we write any line of code in this loop, then it will continue to execute indefinitely. In computer software programming, we avoid infinite loops because our program will be hanged. But in hardware programming, we always write an infinite loop because our program should continue to work in the board and it should never stop. Now the last thing left is, which is the first line in the program. This is RCC AHB1 perif clock command, passing 2 arguments and enabling this clock. Now with this line we are actually starting, or I can say enabling the clock of port D. As I explained a little bit in the previous tutorial also, that whenever we are trying to do something on any GPIO pin, like here we are trying to light up the LED using one of the microcontroller pin. So any kind of situation where you want to configure GPIO pins and do something, then first you have to enable the clock of the port. Now here our green LED on which we are working is connected to GPIO D port. So we are enabling the clock of port D with this line. Okay, now we have understood concepts about the library and we have gone through line by line in the code. Next thing we will do is update this code and make the LED blink in every 1 second. So now to make this LED blink, we'll have to make the LED switch on and off, or in other words we can say that we have to write bit set, then 1 second gap, and then write bit reset, and then again 1 second gap, and then again write bit set on the GPIO PD12 pin. And if we do this continuously, then it will look like the LED is blinking. Now to do that, we have to just change this bit set to bit reset. Let's do that. Now you can see my screen that I have made the 12th pin first set and then reset. That means once I am writing logic 1 and then I am making it logic 0. And we need this logic 0 and logic 1 to continuously execute infinitely. So to achieve that, we have to move these 2 lines to the while loop, because as I said that the while loop has no conditions. So whatever the statement we write in the loop, it will continue to execute forever. Okay, before we go further, let me show you how the while loop will work here. Now let me draw a while loop. Now in this while loop, let's say we have some statements, let's say 3 statements. Then as I said that this while loop has to be an infinite loop, and to make this infinite we do not have to put any condition in the while loop, which we generally do in case of software programming. So it will execute like this: the first statement, and then second statement, and then third statement, and then again first statement, and then again second, and then again third, and then again first, and in the same way it will continue to execute forever. While in reality it can be stopped in between and we can execute some other statement also using interrupts. But that's a complete different topic. For now, just keep this in mind that the loop will continue to execute forever. Okay, so now let's get back to our program. Okay, so let's move the lines to while loop so they can continue to execute forever. Although this program is still incomplete, but let's run it now on the board and see what will happen. So to run this program, first save it, then right click on the project and then click on build project. Now the program is built. Now let's run this program. To run it, click on run and then debug. Now the debug mode is opened. Now we have to click on the resume button and the code will start executing on the board. Let me show you the discovery board and then I will click on the resume button. Okay, now as you can see the discovery board, currently no light are switched on. Now I am clicking on the resume button and see what will happen. You can see now the green LED is continuously switched on. although we have written bit set and bit reset both, but still we are seeing the LED is continuously switched on. So what do you think could be the reason? Well, I know you may have already guessed that it's because our program is not complete. Well, in reality, the LED is actually switching on and off here, but we haven't put any 1 second gap between the off and on, so the two statements that we have written in the while loop are executing by the microcontroller so fast that we see it like it is continuously switched on. Now let's get back to our program. Okay, these two statements are executing so fast one after another that we see the LED continuously switched on and not blinking. Now how to make this LED blink? For that we have to add some delay here, so that once LED is switched on, the next statement of LED switched off should execute with a delay of approx 1 second. Now to get that delay, we have to write a small function here. Let's write that function. As you can see that this delay function takes an integer argument, and then this function will continue to decrement the argument until it is 0. Now I am calling this delay function here. Now I have written 1680000 here, but we can write any big number here, so the delay is enough to make the LED blink slowly and we can see it blinking. For now, just understand the sequence of statement execution here. First the LED will switch on with this statement, and then the execution will be delayed here until 1680000 becomes 0. Then LED will switch off using this statement, then again delay, and then again LED will switch on, and then again delay, and then again LED will switch off, and then again delay, and this whole sequence will continue to run forever. Now let me show you how this delay function will work. Let's say we have these two statements written here in the while loop. And then we have written a delay function, and now we have called the delay function in between the statements and passing number 1680000. Now see how the sequence of execution will happen. First, this statement will execute, then delay function and passing a big number. Now the delay function is decrementing the number one by one. Hence 1680000 will be decremented. Now it will continue to decrease until the number becomes 0. Then the execution will return here, and then the next statement will execute. And then again the delay function is called. Now again the delay function will continue to decrease until the number becomes 0. And then again the next statement will execute. So you can see here that we are actually delaying the next statement to execute by using this delay function, because decrementing the large number one by one to 0 takes some time. So that time we are using here so that our green LED will switch on, then some delay, and then switch off, and then some delay, and then again switch on, and continue to this like this forever, so that we can see it's blinking. Now let's get back to our program. Okay, now let's save the program. Now let's build this and run this program on the discovery board and see what will happen. You can see now that our LED is blinking properly, and we can clearly able to see it's blinking. which we are not able to do earlier. Although the blinking is not following a accurately 1 second gap, but still we can see it is blinking. Hence, adding some delay is working properly. That's great. Now I have written 1680000 here, but you can try with other number and see what is happening on the LED blinking speed. Like if you write a small number here, then your LED blinking speed will increase, and if you write a bigger number here, then LED blinking speed will be slower. So you can try that by yourself. Although for now we see it blinking, but still it is not 1 second delay. You could try out few numbers and check if you are able to reach near to 1 second delay. I know this is like a trial approach, but for now this is still good. Okay guys, so we have gone through the libraries and learned how to use the libraries in our LED program. Then we have made the LED blink by adding some delay. In the next tutorial, we will understand about frequency or speed of execution, and then we will look how we can make the delay exactly 1 second. As right now we can try to add 1 second delay using the trial approach, but in the next tutorial we'll make this exactly 1 second. Once again, this is Anupam from logicvoltage.com, and thanks for watching. Bye.